Good morning, dear children. Yes, today we will be moving ahead with our next identity, that is identity 3. A square minus b square is equal to a plus b into a minus b. Let us see how we can solve this. First of all, let us try to find whether LHS equal to RHS using our arithmetic method. Okay, let's take our LHS. Our LHS is nothing but a square minus b square. Okay, now how shall we move forward to find a square minus b square? It would be better if we start doing RHS, that is a plus b into a minus b, and see whether it is equal to your LHS or not. Because here you can see that RHS can be solved. Now see what is your RHS. Your RHS is equal to a plus b multiplied by a minus b. Now see, simply you can change it, a multiplied by a minus b plus b multiplied by a minus b. We are simply doing the arithmetic process here. Now see, a multiplied by a will give you a square, a multiplied by b will give you minus of ab, plus now b multiplied by a is ba, you can write it as ab. Okay, now again b multiplied by b, and here you have minus, so minus b square. Children, you can see that here you have minus AB and here you have plus AB. So both of them will be cancelled and we shall be left with A square. This one is minus B square. So A square minus B square. So if you are beginning with your RHS, you are reaching to your LHS. Okay, so you have started with your RHS and you have come up to LHS. So you can say that a square minus b square is equal to a plus b multiplied by a minus b. Okay, now we can solve this using geometrical method also. How we can do? Let us see. See, a square minus b square. What we have here? A square minus b square. That means if we make a square of side a centimeter and then minus b square, again we take a square of side b and we get b square, and if we subtract the area of first square minus area of second square, whatever is left is must be our a plus b into a minus b. So first of all, let us make a square whose side is a centimeter. Okay, let me make a square. This square has each side a centimeter. Children, you have to keep this in mind that the square I am making here should have each side equal to a centimeter. Okay, so now this square is formed and this is having each side is a centimeter. Each side is a centimeter. Let us say each side is a centimeter. Okay, now let us take another square of side b centimeter, and that will be superimposed on this square, and the leftover area will be equal to our a square minus b square. Okay, the leftover place will be equal to our a square minus b square. The square what we are forming now has side b centimeter. It is of side b centimeter. Now see children, you have got this. Now the area of this big square, area of red square is equal to a square, and the area of black square is equal to b square. Okay, now a square minus b square. A square minus b square means the whole red square area minus the whole black square area. So you have to find out the area of this much part. This is the area of which you have to find the part, and this is nothing but a square minus b square. This is equal to a square minus b square. How will you find the area of a square minus b square? See, this is the part of which you have to find the area, because see, this one is b square and the whole area is a square. That means the green part is a square minus b square. This area is a square minus b square, isn't it? Now let us see how we shall get a square minus b square equal to a plus b into a minus b. Let us see. Now children, as I have told you earlier, let us find out the dimensions of each space by bifurcating the columns. Now see here, I am just drawing a line here. Okay. Now after drawing the line here, you can find out, see, this was smaller one was of B side, this was B, this was also B, this was also B. That means this much part is nothing but A minus B. So the area of this particular rectangle, the area of this rectangle is how much? Is equal to, see, a minus b one side and the other side is b. So b into a minus b. This is your area of this green rectangle. Now let us see what is the area of this rectangle. See, this much part is how much? This much part is, see, this one is equal to b. So this much part is a minus b. And this part is completely a. This part is completely a. And again this part is also equal to a minus b. So this part is nothing but this bigger rectangle. This bigger rectangle is equal to how much? This bigger rectangle is equal to a into a minus b. The area of the bigger rectangle is equal to a into a minus b. Okay. Now see, a square minus b square is this L-shaped area. I have already told you. Now this is equal to how much? See, this part plus this part. Okay. So the first part is a into a minus b plus b into a minus b. Isn't it? See, this is b into a minus b and this is a into a minus b. Now children, if you know how to find out the common, you can easily do this. See, a minus b is there in this term also and a minus b is there in this term also. See, we have two terms. This is the first term and this one is the second term, and both these terms have been added by plus. So in the first term you have a minus b as common. See, a minus b here common, a minus b here common. So a minus b if you remove, see, in the first term a is left and you will use this plus, and then in the second one b. So see, you are left with a minus b into a plus b. See how we can use this identity, that is identity 3, a square minus b square is equal to a plus b into a minus b, to solve the sums given in our worksheet. For example, I have taken this one worksheet. From worksheet 3 I have taken this question: 0.1m minus 0.2n multiplied by 0.1m plus 0.2n. Okay, now if you nicely see this, you'll come to know that this is in the form of a plus b into a minus b. Children, see, if you take 0.1 m as a and 0.2 n as b, so here you can see that you are getting a minus b into a plus b. See, this one is a, this one is b. Again, See, a minus b into a plus b, and you know that a minus b multiplied by a plus b should be equal to a square minus b square. So simply you can say that here I have written this a and b just to make you understand, but in the answer in your copy you'll not write like this. You just keep it in your mind that this one is a, 0.1 m is a, 0.2 n is b. Now using this identity you got that this is equal to a square minus b square. A square means your 0.1 m whole square minus b square means 0.2 n whole square. Now children, how will you do this? 0.1 into 0.1, I have already told you earlier, 0.1 into 0.1, see 1 ones are 1, but after the point you should have two places, so 1 and then you put a 0 then come, so 0.01, so this will be 0.01 m square minus 0.04 n square. This will be your final answer. So this way you will have to solve the questions which are given in your worksheet. This particular identity is very important, not only from the point of view of expanding but also from the point of view of factorization. That will come after this chapter, but this particular identity is very important. Let us see one more question to fix this concept, how to solve the given questions. Now see, suppose there is a question, x by 3 minus y by 2, x by 3 minus y by 2 multiplied by x by 3 plus y by 2, x by 3 plus y by 2. See, when you are reading out the question, there itself your mind is getting that this is in the form of a minus b, because you can see here, you can see that, see, if you consider x by 3 as a and y by 2 as b, so you can see that this is in the form of a minus b into a plus b, and you know that a minus b into a plus b should be equal to a square minus b square. So here what is your a? X by 3. So x by 3 whole square minus of y by 2 whole square. So see, x by 3 whole square, this will give you x square by 9 minus y by 2 whole square means y square by 4. So this way you can solve the answer. This is your answer, x square by 9 minus y square by 4. Suppose one more question, let me deal with one more question. Let us erase this. Suppose you have a question, a cube plus b cube into a cube minus b cube. While reading itself, you will understand this is in the form of a plus b into a minus b. Simply see children, suppose you consider a cube as a and b cube as b. So then you can see that this is in the form of a plus b into a minus b, isn't it? So what will be your next step? How will you expand this? The next step will be a square minus b square. Okay, so what is your a here? What is your a here? In the place of a you will write a cube whole square. And what will be you write in the place of b? In the place of b it will come b cube whole square. So a cube whole square minus b cube whole square, because this a cube and this b cube are nothing but your a and b. So a cube plus b cube into a cube minus b cube will give you a cube whole square minus b cube whole square. That will be a to the power of c, power to the power you have already learned, a to the power 6 minus b to the power 6. It's very simple. It can be easily done if you understand the identity properly. Now children, let us see another type of question. One more type of question which children encounter in this in this worksheet are, suppose you are given 81 square minus 19 square. You see 81 square minus 19 square. If you consider 81 as A and 19 as B, then it will become 81 minus 19 into 81 plus 19. See. Now see, 81 plus 19, 81 plus 9 is 90, 90 plus 10 is 81, yes, here 81 plus 9 is 90 and 90 plus 10 is 100. Here it is coming 100, and see here it is 81. 81 minus 10 is 71, okay, and 71 minus 10 is 61, but it is, you have to subtract only 9, so 61. It will be 61. No, 62. It will be equal to 62. 62. Okay. 11 minus 9 is 2 and 7 minus 1 is 6. So, your answer is 6200. So, this way you can solve these type of questions easily without, see, otherwise if you don't know this formula, you have to multiply 81 with 81 and then find the answer, and then 19 into 19, whatever answer you will get, you have to subtract and then get the answer. So this is a very tedious job. Rather, if you go like this, it becomes very, very easy to solve this type of question. So let me go through one more question. Suppose you have to do 367 whole square minus 33 whole square. Let us see how you can do this. 367 whole square minus 33 whole square. Okay. Now see, this is again in the form of a square minus b square. So it will become a minus b into a plus b. Okay. Now see, simply this will become 400. There is no doubt. So 7 minus 3 is 4. 6 minus 3 is 3. And 3 will remain like this. So this is equal to 334. This is 334. And here you can see 367 plus 33, 7 plus 3, 10, 1, 0, 1, 4, 400 into 400. Keep two zeros. Okay. Now see 334 into 4. 4 4s are 16, 1, 12 and 1, 13, 1, 4 3 are 12 and 1, 13, 1, 3, 3, 6. So 1, 3, 3, 6, 0, 0. See, without actually multiplying and getting the squares of both the numbers and then finding the difference, it becomes a very big job. But if you know this identity, you can solve these type of sums very easily. The calculation becomes very easy if you know this formula. Okay, now let us see one more type of question. 12.4 multiplied by 11.6. How will you do this without actually multiplying? See, you can change this number 12.4 and 11.6 in the form of a plus b and a minus b very easily. See, 12.4, just let us say that it is 12 plus 0.4, which is actually visible directly. Now let us see whether 12.0 minus 0.4 gives you 11.6. 10 minus 4 is 6 and 11.6 you are getting. So you can write 12 minus 0.4, that will give you 11.6. Okay, so now you have seen that you have already changed this. You have changed this into a plus b into a minus b. See, a plus b into a minus b. Now what is a plus b into a minus b? A plus b into a minus b is nothing but a square minus b square. What is your a here? Your a is 12. So 12 square minus 0.4 whole square. Okay, you know the value of 12 square, that is 144, minus 0.4 square. 4 into 4 will give you 16, but you have point. So after two places you have to put decimal. So it will be 0.16 minus 0.16. Now children, subtract 144.00 minus 0.16. This you have to know. If you don't know how to subtract a decimal number from a whole number, then the whole sum will become wrong. So you have to subtract like this. 10 minus 6 will give you 4. 9 minus 1 will give you 8, 3 left, so you are getting 3 here, 4 and 1, 143.84 is your final answer. And see, quite easily it has been done without any problem. So children, this particular identity is very, 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 very important if you try to understand it properly. Now see, I'll let you know one more. I'll show you one more question how you can do this. without actually multiplying. How you can get? See, suppose it is 195 multiplied by 205. Children, see, simply seeing at the sum itself you understand. See, 195 is nothing but 200 minus 5, and 205 is 200 plus 5. Looking at the sum itself you will get, okay, you have to do like this. Now see, this is 200 minus 5, that is 195, multiplied by 205 can be written as 200 plus 5. Now see, this has come in the form of a minus b into a plus b. So a square minus b square. So see here, 200 whole square means 4, and then 1, 2, 3, 4 zeros. 2 zeros will be changed to 4 minus 25. Now subtraction part must be done carefully. 40,000 minus 25. So see, 5, 9 minus 2, 7, 9, 9, 3. So 39975. That is 39,975. So identity 3 is one of the very important one amongst the three. Yes, the other two are also very important, but from the point of view of factorization, this identity is very important, children. So try to solve all the questions wherever this identity is used, using the identity only. Suppose you are given 195 into 205, don't try to do it with actual multiplication. Use the identity so that it get fixed into your mind. Don't do 195 into 205 like this. If you do like this, you cannot fix this identity. So to fix this identity and to get the concept into your minds, better use this identity wherever it can be used.